All right, so how do we find out if a function is linear or nonlinear? So first of all, you need to look at linear, and there is a word within that word, line. Linear means it will become a straight line. Nonlinear means opposite of that, so it will not be a straight line. So it's linear if the rate of change is constant. So linear is when rate of change is constant or does not change. So let's look at this next one. X is going up by 1, then 2, then 3, and then 1 again. So far it's not looking like it's linear, but we need to check and see what our change in X becomes. So -6, -12, -18, -6. So now we need to see, is there correlations between the two? So my first one, change in Y over change in X. Change in Y, whoops, that's a 12, over change in X. Change in Y over change in X. Change in Y over change in X. Can these reduce down to the same thing? Well, -6 over 1 stays -6 over 1. -12 over 2 can become -6 over 1. -18 over 3 can become -6 over 1. And then -6 over 1. So yes, it is linear because they all reduce down to the same rate of change. But let's look at the next one. I have +2, +2, +2, +2. So right now it looks like it might be linear. The only way this will be linear is if Y also does the same thing. So -2, -4, -6, -10. So no, my rate of change is switching every single time. For 3 to 4, determine if the graph is a function. They determine if it's linear or nonlinear. So number 3 is a function, right? If I were to put a vertical line test anywhere, so it is a function. So it is a function. But now we need to see, does it have the same rate of change each time? So from this point to this point, it goes down 3 over 1. And from this point to this point, it goes down 3 over 1. So it's function and linear. Let's look at number 4. It will pass any kind of vertical line test. So it is a function. But if you look at that, is that a straight line? No. So it's non-linear. And if it is linear, you have to find the rate of change. Well, the rate of change is -3. So our M is -3 for number 3. Sorry about that. All right, the table below shows the total distance, Y miles, indicated on the odometer of Ariel's car, and the amount of gasoline used in X gallons on a particular day. So let's look at the algebraic equation. So first of all, Y equals mx plus B. We need to find M, and we need to find B. B is the easy one. B is when X is 0, what is Y? 1,000. Now we need to find our change, our rate of change. So it looks like it is going up by 1 every single time. But then it goes up by 30, by 30. It looks like it's going up by 30 every single time also. So our slope is 30, or 30 over 1. So our equation is Y equals 30x plus 1,000. So describe how the slope and the y-intercept are related to the function. Well, this one, so let's start with the slope. The slope is the car is getting 30 miles for every gallon. So the car goes 30 miles for every gallon. And then we're going to look at the y-intercept. The y-intercept is saying that the car started with 1,000 miles on the odometer. So, whoops, the car started with 1,000 miles on the odometer.